Next, we're going to start looking at a slightly different shape. It's almost like a pyramid, but we're going to look at a cone. Now, a net for a cone is really simple. We'll obviously have a circular part up here, which of course is right there, and then this blue part here unravels to look something like this, almost like a fan type shape. And there's basic measurements that are the same as a pyramid. For example, we've got the radius here for a circle. The height is the same idea as a pyramid. But then we start talking about cones. We also start talking about the slant. So that is the length of this part right here. It's actually the radius of this circlish type looking thing. And that's called the slant. And typically it's labeled with a lowercase s. So we have two main shapes. We have a circle and we have this. And to find the surface area is pretty simple. You find the area of this circle right here, which of course is area for a circle is pi r squared. That's pretty simple. And then we also have the area of the slant down there. Now the slant's a little bit different. To calculate the area of this slant is pi times the radius times the s value, which is the slant value. So find the area for the circle part, find the area for the outside conish type part, and then all we have to do is put the two things together. Okay, so let's take a cone. So we'll bring in a cone. So there's my cone. And I will find out my areas of my two main components and then put them together. Okay, so for this one right here, no problem. I can find out the area of the circle. So that is pi r squared. So area is pi r squared. So of course, pi, of course, is the 3.14 value rounded off. I need the radius of the circle. Now, this is labeled as 22 as the diameter. So the radius, of course, is half of that. So that would be 11 squared. So I can calculate then the area of my circle. And that gives me about 380 kilometers squared. Okay, so now I'm going to get the outside part here, that bluish looking part, and find the area for that part. So the area for that part is just pi times radius times the s. Now you might be wondering then, what do I need the height for? Well, the height would kick in for things like situations where you don't have the slant value and you'd need to use Pythagoras with the radius and the height in order to find the slant value. Here we have the slant value, so it's no big deal. So we're going to use pi rs to find the area. Pi, of course, is 3.14. My radius, of course, is still 11. And then I'm going to use my slant value of 24.6 in order to calculate my area of the bluish type part. And that would give me about 850 kilometers squared. Okay, well, now all I have to do is take my two measurements and put them together. I've got 380 for the circlish type part. I've got 850 for the outside type part. So I'll just take the 380 and I will add that to my 850, put them together, and we're looking around 1,230 kilometers squared for an entire surface area of a cone. So now let's look at another question with a little bit different information. So we'll get rid of this and get that out of the way. Put the little part right there. All right, so let's try another question. So here's another cone with a little different information. And what makes this one different? Well, first of all, instead of diameter, we have got the radius, which makes things a little bit easier. But instead of the slant distance, we actually have the height of the cone. So this is a case where we'd have to use Pythagoras because we need to know what that slant length is. So it's nice because it's just a right triangle. We got the A side, which is the 8. The 17.9 can be the B side, and this is to be the C value, and then we can use Pythagoras to actually solve for it. So A squared plus B squared would be equal to C squared. The A value can be the 8, the B value could be the 17.9, not that it really matters which order you put them in. Square them, add them, and then square root your answer to get your C value using good old Pythagoras. So if I use my 17.9 and I square that, I take my 8 and I square that and then I root the two together, I will get a slant value. So it'd be, for Pythagoras, it would be the C value of about 19.6 meters, and this would be my slant value, which I need for my calculation of the area of the outside part. All right, now that I've got everything, I can calculate my different areas. So I'll just start with the circle part because that I find is easiest. That's just pi r squared. I got 3.14 for the pi. My radius is 8. I don't even have to change or anything like that. So 8 squared is 64. We multiply that by 3.14, and we're looking at the area of about 201 meters squared. Now I can find the area of the outside part. If I find the area for the outside part, so that weird coney looking shape, that is pi times the radius times the slant. So pi, I know that's my 3.14, that hasn't changed. My radius is 8, and I found my slant value of 19.6, and I put those together, and then the area of the outside part will be, give or take, about 492 meters squared. So that's all the pieces. So all I have to do now is take my two main areas, I will add them up, and I've got about 693 meters squared for everything. So again, when doing this, make sure you're trying to label stuff, try and stay organized, show your formulas, show your answer. You might even want to show some substitutions. Make sure you try and lay out your work nice and organized, nice and neat, and see how things can actually piece together. Again, when shapes get more complicated or composite shapes, that's going to be really, really, really important.